Hello and welcome back to this further maths walking talking mock. This is June 2014, paper 1, and we're halfway through. So we're on question 11. Here is a triangle ABC. Show that angle B is 60 degrees. Okay, let's see. We could use cosine rule. Or we could use okay, fine. We'll have to use cosine rule. I was trying to think of some way of avoiding the cosine rule, but I guess we won't. Okay. A squared. Oh, wait, so if that's the angle, we want b squared actually. Root 14 squared equals that squared plus that squared minus 2 times that times cos b. Okay, root 14 squared is 14. 3 root 2 squared is 6, because root 2 squared is 2, times 3 is 6. Root 2 squared is 2. If I times these together, root 2 times root 2 is 2, times 2 is 4, times 3 is 12. Okay, so 14 equals 8 minus 12 cos b. Take away 8 from both sides. So that's minus a half. Really? Minus a half? Okay. That's going to give me an obtuse angle. It doesn't look obtuse to me. So that's... I feel like I should have got positive a half. A squared equals b squared plus c squared minus 2bc cos a. It's minus, isn't it? I'm not just making that up. It's minus. Right, I've done some kind of multiplication mistake, probably. No, that seems right. But I think it should be a half. In fact, I'm looking at the mark scheme now, and yeah, it should be a half. A squared equals b squared plus c squared minus 2bc cos a. Hang on a second. Maybe I could show you the mark scheme. How to do this without showing you too much of my house. Okay. Hang on. This is my laptop. Okay. Can you do that? I hope I'm not covering the microphone. Focus. So, I feel like they've done the numbers in the wrong order, because Yeah, so they use the other form of the equation, which I don't like. But they've done that one plus that one, take away that one. Okay. But $18. Oh, I'm so stupid. Oh, I see. Was this the first question of this video? I wonder if I should just restart. No, I won't. I'll fix my mistake. Okay. Root 2 squared is 2. And I need to square the 3 as well, which is 9, so that's going to be 18. So that's going to make 20. It's going to make minus 6. That's going to make half. Yep. Oh dear, I'm so silly. Okay, so cos b is a half, and therefore b is going to be 60 degrees, because I know that. Well, I just know that one from Curly Stan. Okay, hence work out the area of the triangle ABC. Okay, so half AB sine C. Half times half AB sine C would be that. Okay, let's multiply these correctly. 3 root 2 times root 2 is going to be 6, and sine of 60 is root 3 over 2. So that's going to be 3 root 3 over 2. Got there in the end. The line x equals minus 9 is a tangent to the circle centre 8, 20. Show that the radius of the circle is 17. Okay. So, obviously that distance from 8 to minus 9, that point there is going to be minus 920, because it's vertically the same as that, and horizontally the same as that. Okay. So the radius is 17. Yeah, obviously it's 17. Show that. Okay. Can I just write from minus 9 to 8 is 17 units? Can I write that? I think my diagram shows it clearly enough anyway. The circle intersects the y-axis, okay, at A and B. Yep, I can see that, there and there. Show that the length A to B is 30. Nice, okay. I immediately want to draw a triangle. The reason I want to do that is because I know the radius is 17, so I can put that in, and I could do with an angle. Don't really know an angle, do I? So I can't really do anything with that, unfortunately. Oh wait, I know. Oh, I hadn't realised. Yeah, that's the y-axis. Okay, so that length there is 8. Okay, so I could find that length there using Pythagoras. So O to B is going to equal the square root of 17 squared, take away 8 squared. Okay, 17 squared. That would be a challenge. $240, $289. That's going to be 225. Oh, that's good. I can do that. That's 15. Okay, so a to b is going to be 30 then, because it's double that. Can you see? That's quite nice. The curve has equation that. It's a nice cubic. Show that the curve has a minimum point when x is 2. Okay, so I'm going to need to differentiate this. I was about to write plus 5, but I stopped myself just in time. Okay, so to find minimum points or stationary points in general, we have to equal that to 0 and solve it. So I'm going to factorise. So I've got x equals 0 and I've got x equals 2. So 2 is certainly a stationary point, but I haven't shown it's a minimum point. So I'll have to do that by going a little bit to the left, a little bit to the right. So before we've got 1.9. Oh wait, but this is non-calculator. So should I just do 1? I'll just do 1. And after x equals 3. Yeah, normally I would do 1.9 and 2.1, but you know, I'm not so good at the arithmetic. So when x is 1, the gradient will be 3 times 1 squared, take away 6 times 1, which is 3, take away 6 minus 3, which is negative. So it's going down. And after it, we've got 3 times 3 squared minus 6 times 3, which is 9, 27, take away 18, which is 9, which is positive, and that proves that it is a minimum. Cool. Show that the tangent at the minimum point meets the curve again when x equals minus 1. Okay, let me draw this. See how they've left you this blank space before the lines? That's because they know you want to draw it. Right, so let me get this right. It's got x equals 2. It's got a minimum point. At 0 it's got a maximum, and at 0 the y-coordinate will be 5. So is it something like... something like that? The tangent at the minimum point would look like that. It meets the curve again when x is minus 1. Okay. Okay, let's find the equation of the tangent. We know that it's y is... we know it's y equals something. Like, there's no x in it, right, because it's horizontal. So let's find the x-coordinate when y is 2. Let's find the y-coordinate when x is 2, using y. 2 cubed minus 3 times 2 squared plus 5 is 8. Take away 12 plus 5 is 1. Okay, so that's 1. Okay, so the equation of the tangent is y equals 1. We want that to meet the curve. So for it to meet the curve, we want x cubed minus, that's a minus, 3x squared plus 5 to equal this. So we want it to equal 1 for them to meet each other. In other words, we're finding the other point on the curve where the y-coordinate is 1. Okay, and we just have to solve this. Please tell me there's more space. No, they've not given me more space. They expect me to solve this cubic with this much space? What? Although they did tell me the answer, so I could just use the factor theorem and substitute that in. Would that be a bit naughty? Let's just do it. -1 -3 plus 4. Meets at x equals -1. I don't think that's cheating, because surely they don't expect me to solve a cubic. I don't think they do. Let me just check the mark scheme, see what they reckon. Ah, no, yeah, they did it exactly the same way. So, that's fine. X minus a is a factor of that cubic. Show that a is 2. Okay, so by the factor theorem, if x minus a is a factor, then f of a must be a root. So, sorry, then f of a must be 0. Great. Yeah. So I'm substituting a into x, which was kind of confusing because it also had a's in it. I thought I might be doing it wrong for a second. So that's going to be 2a cubed minus a cubed minus 16. Oh, and it has to equal 0, so I put equals 0. So that's 3a cubed, take away, that's 2a cubed minus 16 equals 0, so equals 16. Let's put some. Okay, so a cubed equals 8, so a is 2. Show that a is 2, okay, yep, it does. Now solve it. Right, the fact that this is part B means that it has something to do with the previous question, which means that 2 is definitely going to be a factor. They've given that as a clue. Can you see that this relates to that? If a was 2 times 2, and that's 2 squared, yeah. Given as that as a clue. So 2 is definitely going to be a root, or x minus 2 is going to be a factor. So let's just check it, just in case. But they were just giving us that as a clue because, you know, you have to start this process by guessing, and you could be there all day guessing, which could really ruin your exam. So x minus 2 is a factor. Okay, right, so here's the question. Do you want to guess the other 2 factors? Well, we just need to guess one more, and then the other one we can work out. Or do you want to do polynomial log division? You know what? I don't even have to ask you. I know exactly what you want to do. You want to do the division. Because everyone loves polynomial log division. I know I love it. Okay. How many times does x go into x cubed? The answer is x squared. And then, so I divide, yeah, x cubed divided by x, and I put the answer there. Step 1 is divide. Next step is to times x minus 2 times x squared. Divide times. Subtract. Take that away is nothing. Sorry. That take away that is 6x squared minus 4x, take away nothing, minus 16, take away nothing, okay. And then we repeat, divide, so 6x squared divided by x is plus 6x, times, so we do 6x times x minus 2, subtract, that take away that is nothing, that take away that is 8x, that take away nothing is that. then we go back to the beginning, so we divide 8x divided by 8 is, 8x divided by x is 8, okay, times x minus 2 times 8 is that, subtract, nothing, so we did it right, so it's x squared plus 6x plus 8, which I can factorise as plus 2 and plus 4, so x is 2, or minus 2, or minus 4. Prove that, ooh, this looks good. Sine theta minus sine cubed theta over cos cubed theta is identically equal to tan theta. Okay, so we're just going to take the left hand side. We're going to ignore the right hand side for now. You're not allowed to use the right hand side and the left hand side because then it wouldn't be a proof. It would just be like you're trying to solve it or something. Okay, let's factorise the top because I've got a good feeling about that. Okay, I know that 1 minus sine squared is cos squared, so why not change that? Okay, and then I've got cos squared on the top and cos cubed on the bottom, so I can cancel cos squared with one of those. So I end up with sine theta over cos, with two of those, so I end up with just one left. So I get sine theta over cos theta, which equals tan theta, or is identical to tan theta in fact, which is the right hand side. So I have proved it. And the last question, got an identity, work out the two possible pairs of values of a and b. So I'm going to expand the bracket over here. So I've got two lots of x squared minus 2a plus a squared plus 3. So 2x squared minus 4a plus 2a squared plus 3. Okay, let's compare common coefficients. So let's just ignore the 2x squared because that's the same on both sides. Okay. Then we've got, if I look at the x's, forgot the x. If I look at the x's, I've got minus 2bx and I've got minus 4ax. Okay, so minus 2b equals minus 4a, so b equals 2a. Okay, can't solve that yet, but I'll bear that in mind. Then equating the non-x bits, I've got 7a equals 2a squared plus 3. Okay, this is a quadratic, so let's put it all over to this side. And can I factorise that? Times to make 3, add to make 7, yeah, I can do that, that's fine. So a is a half, or 3. Okay, if a is a half, b is going to be 1. And if a is 3, b is going to be 6. And I'm just going to check the mark scheme to make sure I got it right. Yep. Cool. And that's it, that's the end. I do have the grade boundaries written down. Let me show you. Oh, where did I put it? I wrote down the grade boundaries for this paper. Oh, well, not just this paper, but combined with paper 2 as well. So you can see that if I'd done this paper, bearing in mind I did get one question wrong. What did I do? Oh yeah, that stupid 3 root 2 squared. I reckon I still would have got 82% though. So that was a nice A double star for me. Not that I should be proud of that, but you can see, like I keep saying, you only need half of it correct to get an A. And 65% for an A star, which is quite generous. Okay, you can all achieve that. All of you can definitely achieve 65% in this paper. So, anyway, oops. I will see you later for paper 2.